Please open to page 219 in your student journal. Today in section 7.4, we're going to be solving polynomial equations in factored form. Now, just reading the title of the lesson, you might be thinking, oh my gosh, Miss Callie, what are we doing today? So let's just break it down. And let's start just looking at exploration 1, and we're just going to look at the different forms. We are used to standard form. Standard form means we write our polynomial in order, highest exponent to lowest. So if we look at all the equations in that second column under standard form, we have x to the second power listed first in each one, and then we have all of our x to the first powers, second, and then last but not least we have that constant, which means it's just a number, there's no variable at all. Now, the new part for us, though, we've been working a lot with polynomials, but we haven't been working with the equations. So now we're going to start seeing the equal signs. And for a polynomial equation to be in standard form, it needs to equal 0. For a polynomial equation to be in standard form, it needs to equal 0. Now, in order to solve those equations, we need them in factored form. Factored form is where we have a product set equal to 0. We spent the last couple sections multiplying these two binomials together. Now we're not going to multiply them, we're going to use them to solve the equation. So notice factored form means we have a product. Product means we're multiplying. We are multiplying these two binomials together to equal 0. So factored form is where we're multiplying, we have a product. Standard form, we have our polynomial, highest exponent to lowest exponent. So let's go ahead and turn to page 221 in your student journal. And we see the idea of the zero product property. It's a property you're all familiar with, but maybe you've never actually used the word zero product property. And all it means is if the product of two real numbers is 0, then at least one of the numbers is 0. So in other words, if you're multiplying two numbers together and the result is 0, that means one of the numbers has to be 0. So we see in the symbol piece, the algebra piece, if a times b equals 0, then that means that either a is 0 or b is 0. They could both be 0. 0 times 0 would still get me 0. So now we're going to use that idea to help us solve our polynomial equations in factored form. We have factored form. Again, it's a product. These two binomials are being multiplied together. When we multiply, we have a product. So if we can get, from multiplying these two things together, if we can get either this piece to equal 0 or this piece to equal 0, our product will be 0. Our end result will be 0. So let's think about how could we get x minus 1, how could we get that piece to be 0? Well, we could set up a little equation, solve the one step. So when x equals 1, x minus 1 should be 0. Let's check. If I substitute 1 in for x, 1 minus 1 is 0. 1 plus 2 is 3. 0 times 3, I do get 0. So by figuring out what to put in for x to make x minus 1 equal 0, we came up with one of our solutions. Again, as long as I get one of the things I'm multiplying together to equal 0, my whole product will be 0. Let's see if the same holds true let's see what we could get to make x plus 2 equal to 0. See, I'll subtract 2, x equals negative 2. Let's check. Get negative 2 minus 1, negative 2 plus 2. Negative 2 minus 1 is negative 3. Negative 2 plus 2 is 0. Negative 3 times 0, I do get 0 equals 0. So negative 1 and negative 2 both worked to make my equation equal to 0. So do I need both of those solutions? Yes, because they both make my equation true. So how we'd write our answer, x equals 1, or x could be negative 2. We want both of those. And again, when I check this, I just substitute it back into my original equation. And that's a great way to check. So let's try this out with just a few more examples. Please go to page 222 in your student journal. Let's take that idea of that zero product property. In number 1, I'm multiplying together x and the binomial x plus 5. I'm multiplying those two things together. Now I know it's very tempting to distribute because that's what we've spent the last two sections doing, is distributing. But now we're trying to actually solve those equations. So I want to either get x to be 0 or I want to get x plus 5 to equal 0. Let's see what works. The first one's easy. I just set x equal to 0 and I'm done. Let's check to see if it works. I'm going to put 0 in for x wherever I see an x into that original equation. 0 times 5, 0 equals 0. That one works. Now let's see if we can get x plus 5 to equal 0. Now I like to set up these little one-step equations and solve them. If you can tell by looking that x could be negative 5, that's fine too. I just want to check this. I just want to show you that it does work. Again, wherever I see an x, I'm putting a negative 5. Negative 5 plus 5 is 0. I have to do order of operations. Negative 5 times 0 is 0. So my solutions, yes, I need both of them. X equals 0 or x equals negative 5. I do need both of those solutions. Why don't you pause here and see what you can come up with for the solutions to number 3. In number 3, I'm multiplying together 5p times p minus 2. If I can make 5p or p minus 2 equal to 0, my whole product will equal 0. So 5p, what can go in for p to make that equal to 0? Divide both sides by 5. 0 divided by 5 is 0. How can I make p minus 2 equal to 0? When p equals 2. Those would be my two solutions. You can, and I highly encourage you when it comes to your practice or a quiz or your test, substitute those solutions back in one at a time and check to make sure that they work. Now the first few we've had some nice one-step little equations to solve. Now in number 5, we crank things up just a little bit. I'm multiplying 2b minus 6 times 3b plus 18. If I can get either of those binomials to equal 0, that entire left side will equal 0, and we have our solutions. So how can I get 2b minus 6 to equal 0? And then how can I get 3b plus 18 to equal 0? Go ahead and solve the little equations that result. I get b equals 3. Subtract 18. b equals negative 6. Just want to look at just a couple more. We take a look at number 7. Number 7 was one of our special cases when we were multiplying. Remember, the squared means it's going to be x minus 3 times itself. So what we have is we have x minus 3 times itself. So how can we get x minus 3 to equal 0? And then we end up with how do we get x minus 3 to equal 0? I don't need to solve the same thing twice. So in this case, we just have one solution of x equals 3. I don't need to solve the same thing twice. I just want to show you number 11 because now number 11, we're multiplying 3 things together. And that's okay. If I'm multiplying 3 numbers together or 4 numbers, as long as one of them is 0, the whole product is 0. So the end result will be 0. So the 3 things I'm multiplying together, I'm just kind of highlighting those right now for you. So if we can get g to equal 0, 6 minus 3g to equal 0, 6 plus 3g to equal 0. So in this case, we're going to have 3 different solutions that could work. G equals 0, that's already solved for me. My second one, I have to subtract 6. Be careful, we're left with a negative 3g equals negative 6. Divide by negative 3, g equals 2. Again, we subtract 6. Positive 3g equals negative 6. Divide by positive 3, g equals negative 2. So for this one, we could have g equals 0, or g equals 2, or g equals negative 2. Yes, I do need all 3 solutions. One will not cut it for us. So the big idea in this section, we're solving our polynomial equations in factored form. The thing I want to stress, do not multiply, do not distribute the equation. Do not distribute. It's already factored for you. In our next unit, we're going to look specifically at factoring. So this is just getting us ready for that piece. We'll learn how to factor next unit, and then we'll continue solving these types of equations. So this is just our first step. You're given factored form. How do we solve when we have factored form? At this time, what I'd like you to do is try out your progress check. Use any of these notes you'd like on it. Check it, and let me know how you did.